Hi everyone. So now I'm going to show some plots. So plotting our data is a really important part of statistics. Any kind of fancy statistics that we do, we always have kind of assumptions underlying that about how the data is distributed, what it looks like, and we always need to keep our eyes out for data points that are going to really affect our analysis quite a lot. And so we get some picture of how it looks from here, but let's dig deeper and look into what our data looks like, get some pictures of our data, and R has some really great and very powerful functions for doing this. So let's do the dot plot first. So we can, again, just search for dot plot. So dot plot for a single group. And notice there's instructions for each of these variables about what you need to replace in each of them. So we have another function here. So this is the name of the function. And again, we have the same response variable that we're doing, but we have a few more things that we want to describe. So first we want the name of the data. We had that before. And then main is what R is looking for to specify what the title of the plot is, like the whole title. And then xlab gives the label for the x-axis. So we describe it using that. So we can copy and paste this whole code chunk. And so now we need to make those replacements. So of course we want life.expect.both. And then we want our data name, which is countries. And then now we change the title of the plot. So I'll just follow the instruction in the instructions for the discussion assignment. So this is dot plot of average life expectancy for world countries. Oops. And notice, there's still a main argument. So this is, R is looking for things with these names in order to know what to do. But we've just changed what appears there so that R can do something different than the sort of default that was given in the template code chunk. And then the name of our response variable is average life expectancy. Years. So you can run that dot plot, and we get a plot of that. And the other plots are quite similar. So we can search for all of those code chunks again. So then we search for the histogram for a single group. And so replace response variable again with life expect.both, data with countries. I'm going to crib the labels that I had in the previous one because I'm using the same title and the same label for my x-axis. So I'll replace those. So I have the main and the same X label. Notice that I have a few different things that R is doing, and I put commas between them. There's a new argument called type equals count, which tells R which type of histogram to create. So there's our histogram. And then finally, I will do the box plot. So I'll just search for box plot. Box plot for a single group. And you notice that some of these they share a few arguments, but sometimes they have other arguments. Here's outer equals true. I don't 100% remember what that means, but it's something that creates a dot plot that's a little bit more like what we expect. So I paste that code chunk. I put some other stuff in there by accident, so I was just deleting that. Sorry for any confusion. Sometimes my fingers do things that I don't intend to do. But anyway, so I have that same code chunk, and I just replace the same arguments that I did before. In fact, I'm going to copy all of this part because it's all the same. Be a little bit careful about copying between different functions. Sometimes you want to make sure your end result still makes sense. I still have commas between everything. I don't have any extra parentheses and anything like that. So everything was good. And I get a box plot. Congratulations, a box plot. So we've gone from just setting up our file to already having some really interesting and fairly publication-ready plots in R already, and that's part of the power. And it takes a little bit of fluency to be able to come back and do this again and again, but with some practice, it's just like learning a language. You'll sort of, gain more and more fluency with different parts as you practice.